Okay. So we just made a little grid, and we're trying to keep track of what we have here. So I've circled the numbers that we've already dealt with, which is actually interesting. I hadn't really appreciated the symmetry in those numbers until we made this grid. But we said you win with an 8 out of 36 chance on the first roll. That's a 7 or an 11. And then you lose with a 4 out of 36 chance. That's a 2, 3, or a 12. So what's the probability that you get a 4 on the first roll?
Looks like it's 3 out of 36.
All right. And then we're going to have to figure out what are chances of rolling a 4 before a 7 after that. How about a 5?
5, we get 4 out of 36. 6, we get 5 out of 36. 8, looks like you get 5 again.
Mm-hmm.
And then 4 out of 36, and 3 out of 36.
Yeah, okay, great. Now let's just pick one of those numbers, and then, because once we solve it for one of those numbers, by it I mean, pick a number.
Let's just do 4.
Yeah, 4.
Okay, so 4. When we do it with 4, so we roll a 4, and so now we're into this third case with the number 4. Now we have to figure out the chance of rolling a 4 before we roll a 7. Now, does the fact that we just rolled a 4 matter?
No, it doesn't.
Why not?
Because it sort of enters us into a new case, and this is completely random.
Right.
They're independent events.
Yeah, the dice don't remember that they just rolled a 4. How about that? I rolled them out and I got a 4. That's two little miracles so far with these dice. But now we got to figure out how are we going to test or determine the probability of rolling a 4 before rolling a 7 now.
Well, it looks like 4 rolling a 7. It'd be kind of difficult to look at it maybe in cases, but if you did maybe if we calculated that, we know the probability that we roll a 4 and a 7. So if we sort of did cases for each, and then if we did also the loops, and we could just see what that sort of converges to.
Okay. Do you have any ideas?
Well,
So that's a long computation if we're going through those loops.
Well, we know 4. So 4 is about half as likely as 7 to show up.
Okay.
So we know that the probability of rolling a 4 before a 7 is going to be pretty small. But I'm not too sure how we would go about calculating
Okay.
how to do it.
All right. Yeah. So one is we could do a big calculation of an infinite series, which I don't actually want to do that. I want to show you a neat idea here on probability. So let's look at our grid that we made here. So, and we're taking about the case with the 4. So what happens if I roll a 3 now?
If you roll 3.
While we're in this case.
With like a sum of 3? Or like a 3
No, I roll a 3. So I
Okay.
roll the dice, I get this. 2 and a 1, so I get a 3. What happens now?
We're just going to go back and roll again.
Okay, so the 3 doesn't matter. What happens if I roll an 8?
Doesn't matter. We're just going. We go until we roll a 4 or we roll a 7.
Okay, so with this red marker, can you circle the numbers in this case that matter in our game?
So we need to. It's these numbers and 7.
Okay, so for our game we're playing right now, only the numbers that are circled in red matter.
Yeah.
If I roll any other number,
You just
We roll again.
do it again.
it's as if nothing happened, right?
Yeah.
So does that give you a hint as to how you can figure out what the probability of rolling a 4 before you roll a 7 is?
So I mean, we could look at the probability of we could use choosing numbers because we've got 9 things and 3 of them are a good case, so maybe we could say like 9, choose 3
It's
is our
probably
probability.
winning.
Or it's not really a probability, but it's the number of ways we can win.
Yeah, but we're not choosing 3 things here.
We're rolling.
We don't choose 3 out of these 9 things.
We're just choosing one. We're just kind of like throwing it at a dartboard and seeing which one it lands on.
Right. It's as if we're throwing at a dartboard that only has these squares circled, and those are the only ones we can hit.
So I mean, then you could maybe say it's a third
Why?
because you have 3 good cases, 9 total cases. It's probably of getting one of these 3 is 1/3.
Aha. So the probability of winning by getting the 7 is bad, right?
7 is
7
bad.
is bad.
Yeah, 4 is what you want.
Okay, so we have 3 good outcomes out of 9 total outcomes.
And then the 10 also.
Do you see why it's not choosing numbers? We're not choosing 3 things from 9 because we're not. That would mean we have to do like 3 rolls, or we have 3 things we've grabbed. But in fact, it's only 1. Once we're throwing darts at a board, that's a great way of thinking about it. And we can pretend that the board only has these squares on it, the red ones, because the other ones nothing happens.
Yeah.
We just keep throwing until we hit these. Okay, so why don't on the next video, why don't we calculate the 5, 6, 7, 5, 6, 8, 9, and 10? All right.
All right.